So following on from sudo privilege escalation, this is another way if you have access to a sudo command that you will be able to escalate privileges and doesn't require a specific application, more so just that you have access to the sudo utility on any application, and it utilises shared libraries in Linux. So if you're familiar with programming or anything like that, you're shared in static libraries. Shared libraries are used to prevent code duplication. In normal circumstances, they're sensible and it's efficient and it's a good usage. But in this instance, if we have sudo privileges, exploit it by running unsigned code, essentially. So on there, we can exploit perfectly useful non-benevolent functionality to load malicious code. Sudo is crucial here, so if we don't have sudo privileges on binary, we cannot load a shared library. That's the key bit. Obviously, where it comes in, you shouldn't be able to load code as a privileged user if you are an unprivileged user for obvious reasons. So how this is going to work is we're going to create a nice simple malicious script which is just setting our user ID and group ID as 0, and that'll basically give us root. So the process of it is start the application, unsets the environment variable preload, sets the user ID 0 so the program's run as root, group ID 0, run as root essentially, and it'll spawn a system shell as a root user, and that is how simple this works. As long as we have sudo access and we can compile this either on the machine or we can compile it on our machine and file transfer it over some way to the victim machine, we should be able to exploit preload functionality. So to finish the exploit, this is how you'll compile it. You'll compile the C code with the FPIC parameter, which makes it position independent. So essentially that stops in normal cases it crash if it's not compiled. I've not actually tried it without that flag, so it'll probably still compile, but it probably wouldn't work, I imagine, as that just ensures that the code can be run anywhere inside the address space and not at a specific place in memory. I'll leave a link if you want to learn more about that. It's just a small change rather than using like static addresses, things like that. It's more of a relative thing. So as I already said there, can be transferred to the victim machine or compiled if the machine has GCC installed on it. If it doesn't, as it's already said, it's easy enough to do, is transfer it over. And then there we go, running the exploit. To perform the privilege escalation, run whichever sudo command you can with the LD preload parameter. So for instance, if we had sudo privileges on nano, sudo LD preload equals and then the path to our file name, you'll want to make sure that that is an absolute path, otherwise you could run into issues. It says there, and now I'm going to be going over a live example of this in action. So here is a good example of a bad example, and I'll explain why this didn't work. So when I first did this box, and just so I've done it now, I haven't actually realised my mistake, but I noted this one down, but I'm now going to explain where I went wrong. So in order to determine if you can execute LD preload, you see here these environment variables here, it will say if this sort of exploit will work, env preload. So under the path, env reset, all this jazz here, it will say preload underneath here, and this will be able to tell you if you're able to run preload variables. It's not set by default for sudoers, but we're gonna go through this example anyway, as if it would have worked. I'm just gonna go through it. So all I've done is include my script there. I compiled this on my own machine and transferred it over from a Python script. There you are. And then we've just ran our sudo command, which I've checked we can run through sudo-l, and it's told us that we can run monitor.sh. All this down here is just the reason why I asked for a password is because monitor.sh did not exist, so I had to make it exist by doing some stuff on the box. Upon running it, it's told me, sorry, you are not allowed to set the following environment variables LD preload. If this environment variable was up here, it said, you know, you can set it. This exploit would have worked. I haven't actually got a box at hand now that I can show this working. However, on Try Hack Me, I know that they do exist. Things like that. It's a very common one to see. It's nothing too major. So I'll leave a link in the description if you want to try it out for yourselves. Everything that I've just shown here, if you do it, and it says on sudo-l that you have the env ld preload, you've got rights to set that, you will be able to escalate privileges that way. Just really quick before I end this video, this is day after I managed to actually get my VPN working, so I'll just quickly demonstrate what I mean. So when you run sudo, it'll tell you the environment variables you have access to here, as I already explained. And obviously in the previous example, we didn't have this one here, telling us that the preload variable can be set essentially. So all I've done is just move my shared object file over, set the preload variable, ran one of the commands we can run a sudo, and immediately got a root shell. Simple as that.